This one should be pretty easy. Remember, we're using inverse operations to isolate our variable, so we want that to be like this. I'm going to do plus 20, get rid of a constant first. We get 3m equals negative 2. Divide both sides by 3. It says solve and check. And then x equals negative 2/3. So if we do our check, we get 3 times negative 2/3 minus 20 equals negative 18. Let's see if that's true. Well, this 3 and this 3 simplifies to 1. Hang on a second. Oh, this should be positive 2. Apologies. This will be positive 2. So that's a positive 2. And positive 2 minus 20 is negative 18, which equals negative 18 on the other side. Okay. We're going to, well, multiply by the reciprocal. We get 5 over 3 times 5 over 3. So think about it. How can I isolate my variable? What can I do to 3/5 a? So I get just a. Well, I multiply by this reciprocal. Everything here simplifies to 1. I get a, and on this side, let's see, 30 divided by 3 is 10 times 5 is 50. A equals 50. Do your check. We get 3/5 times 50 equals 5/3. I replaced the a already, right? I replaced the a here with 50. 5 and 50 can simplify to 10. Did I copy this right? Right, something's not right here. Sorry. Let me just start all over. Times the reciprocal, 5/3 times the reciprocal, 5/3 cross simplifies to a. Let me put the line here, and then 5/3. Then do the reciprocal on that side. Did I? No, so it's 10. No, it is 10 divided by 3 is 10. 30 divided by 3 is 10 times 5 is 50. So the check is 3/5 of a, which is 50, equals 30. Oh, that's what I messed up in those 5/3. Anyways, this simplifies to 10, and 3 times 10 is 30, which equals 30 on the other side. I should have slipped. Mine is not working. Distributed property. We get AP plus 96 equals 104. Subtract 96 from both sides. That goes away. 8p, 14 and 6 is 8, 9 and 9 is 0. And we're left with just 8. Divide both sides by 8, and p equals 1. How nice is that? Substitute, you get 1 plus 12 equals 104. This 13, 104. So inside the parentheses, you can do the distributive property, or you can just do order of operations. 1 and 12 is 13, right? And then 8 times 13 is indeed 104, which is equal to the expression on the right side. Again, we're going to do minus 12. It's 12. That goes away. C over negative 4 equals negative, what is that, 50? We're going to multiply both sides by negative 4. And we get C equals 200. Let's see if that's true. Check 200 over negative 4 plus, sorry, you can't see, plus 12 equals negative 38. Let's see if that's true. 200 divided by negative 4 is negative 50. And if I add 12 to that, does it equal negative 38 on the other side? Yes, it does. So, okay. Translate to equation. Okay. I'm going to translate first and make any adjustments later. 8 less than, which is minus. Twice is 2 times a number. Number, I forgot the b. 2 times the number is 17. So let me take this out. Do we have to make any adjustments? Yes, because of this word. So it's actually 2x minus 8 equals 17. Second one, 3 times the sum of a number. So because it's a sum, right, and it involves more than one term, of course, we're going to put in parentheses 3 times the sum. What am I adding? A number plus 7. There you go. 3 times this sum over here is negative 5. The quotient means division, and who am I dividing? A number. Here's a number that I don't know of, and negative 3, and divide by negative 3, plus 5 equals Write an inequality to represent each statement. Okay, you must be older than 18 to enter the club. So I'm going to put club, and the age that you have to be in order for you to enter, you have to be older than 18. If you're 18, can you come in? Nope, you can't. She has to spend at least $10 to get a bonus gift. So let's call gift, G for gift. In order for you to get the gift, whatever you buy has to be greater than 10 or even equal to 10. Maximum number of students allowed is 33. So use max, M for max. And max is 33 or less, which in this case is the less than or equal sign. You need to get a minimum of 65 to pass this the class. So let's use P for pass. In order for you to pass, you have to get greater than 65 or even equal to 65. Graph, solve and check, so a little bit more practice in this. Right, so again, it's more about you knowing the property of inequality and what happens when you multiply it by a negative number. We know that when we add and subtract, right, the same number to both sides, the order of inequality stays the same, but when we multiply, things change a little bit. So in this case, divide by negative 3a, divide by negative 3a, negative divided by negative is a positive, and we get a, and then the sign has to be switched, negative 5. Graph, in this case, we want numbers that are less than negative 5, and they are to the left, and negative 5 is not included. What are we doing here? Okay, minus 10 on both sides. That goes away. M over negative 5 less or equal to 10. We're going to multiply again both sides by negative 5. Right? Negative multiplied by negative, divided by negative is a positive. They both simplify to 1, and M stays isolated. So the sign goes the other way, and 10 times negative 5 is negative 50. So your number line is negative 50. And we want numbers that are equal to negative 50 or greater than negative 50, which is every number to the right. Again, you can always substitute and check, right? Pick a number, a large number, and substitute for the variable and check. Right, so, okay, more problems. We're going to do minus 10, you get negative 16 less than 4p, divide both sides by 4, you get negative 4 less or equal to p. Number line, again, in this case, negative 4 is not part of the solution, and negative 4 is less than what number? So all these numbers have to be right to the right of negative 4, because that says negative 4 is smaller than all these numbers represented by p, and numbers represented by p are to the right of negative 4. Minus 12 goes away, negative 9a greater than, what is this, 8, 11 minus 2, 9, divide by negative 9, divide by negative 9, and again, I guess we're just reinforcing the order of inequality and what happens to it when you divide and multiply both sides by a negative number, and that's what happens. Negative 1, do we shade? No, we don't shade. We want numbers less than negative 1, and they are to the left of it. All right, moving along. Here we go, write and solve an equation. All right, Sam rents a car. Again, I think we did already this one on the previous video, so I'm not going to do this one. Gary went to the hobby shop, bought 5 kites. Oof, I got to make one for the summer. For $9.95 each, and a few balloons that cost, 75 cents. So how much do we actually know? What do we know? We actually know something. We know the exact value for the kites. So that I can write. So what's 9.95? What is it? 5 kites. So we spent 49.75 for the kites. Plus, we bought balloons. I don't know, a certain quantity of balloons, but I know that every balloon is 0.75 cents. The total I spent was 55.75. How many balloons? So this is an equation, so equals 55.75. And that's your equation. Subtract 49.75 from each side. And I'll give you that answer. Equals equals 6. So 0.75 balloons, and I have $6 over here. And then $6 by 0.75, that means if I divide this by 0.75 and divide this by 0.75, the number of balloons I bought was 8. Now they won 91 super bouncy balls playing basketball at the county fair. At school, she gave 3 to every student in her math class. She has only 1 remaining. I mean, students are in her class. So the 1 remaining plus, what is it? B, what variable should I use? How many students? How many students? So every student got 3 balloons, right? I'm going to write 3 times the number of students, and that gives you 91, equals 91. So that's my equation. So I'm going to subtract 1 from both sides. Okay. 3s equals 90. Divide both sides by 3. The number of students in her class was 30. Field trip. 5 students rode in a car, and the rest filled 10 buses. How many students were in each bus if 215 students were on the trip? Oh, okay. So something equals to 250. The 5 students that were in the car, plus 10 buses with how many students per bus? We don't know, so let's call that, I don't know, call B. Let's say 10 buses times however many students per bus. And that's should have been your equal sign. Minus 5. We get 10s, right? 10 buses plus 10 buses with a certain amount of students in each bus equals 210. Divide by 10, divide by 10. The number of students in each bus was 21. Okay, so Adam rents bikes for $19 plus $18 per hour. He paid $67 to rent the bike. How many hours did she rent the bike? So just to rent the bike, you have to pay $19. And then on top of that, you pay $8 per hour. So Nicole paid 67, right? So think about it. So Nicole paid 67. Out of the 67, 19 was just the bike rental. Right? So, that's an 8, 5 minus 1, so 48. And then this was how much she spent for the hours, right? And if it was $8 per hour, how many hours is that? Well, obviously 6. But how do we write that as an equation? So the total was 67. 19 was just for the bike, and then $8 per hour. And there's your equation. Minus 19. Get 8h equals 48. Divide both sides by 8. And h equals 6. So she rented the bike for 6 full hours. Tom bought 3 yellow balloons and 4 yellow balloons for $350. All the balloons were the same price. What's the price of 1 balloon? What? Hang on a second. So 7 balloons times whatever the price was equals, let's call P for price. 7 balloons times whatever the price, I paid $350. Divide both sides by 7. The price per balloon obviously was 50 cents. Next set of questions, inequality. So this just gives you a little more, I guess, more practice. Right. Ben rents a car. Again, the car problem, which is very popular. You gotta just be careful on your test. If they ask you for an equation, you have to, if it's an inequality, use an equality symbol. Just don't make sure that whatever they ask for, don't give me an equation when it's an inequality or inequality when it's an equation. So just be careful with that. Ben rents a car that charges $20 per day plus 12 cents per mile. Well, $20 just to get the car. And then on top of that, I'll pay 12 cents per mile driven. The maximum he can spend is 70. So however many miles I drive, right, the cost of it plus the car rental has to be less than 70 or even equal to 70. How many miles can I drive for? So minus 20, minus 20. That makes sense, right? So out of the $70, I take 20 away. It's left I'm left with 50. So I got to figure out with 50 bucks, sorry, how many miles can I drive with 50 bucks? Divide by 0.12, divide by 0.12. The number of miles that I can drive is 400. Wow, really? 416. And I guess 2/3 of a mile. If you don't want to round it, sorry, if you don't want to, as a decimal, which can happen. You can actually drive 416 and 2/3 of a mile. Okay, so be careful here. It's not like when we're talking, can I do 416 and 2/3 of a box or 2/3 of a person? That obviously is not true, but I can drive. So the maximum number of miles is 416 and 2/3 or less, and I'm okay with 50 bucks that I had remaining. Then you had 15 to spend at the fair. Okay, so here is his $15. So whatever he spends has to be less than 15 or equal to 15. The admission to the fair is $2.50 and the rides cost $1.75. So to get into the fair, you pay $2.50 plus $1.75 for each ride. How many rides can he go on? What's the greatest number of rides he can go on? Well, minus $2.50 minus $2.50. We're going to get 1.75 R less than 12.5, right? Divide both sides by 1.75. And R is, no idea, 12.5 divided by 1.75. 7.14 rides. So, now in the context of this story, the number of rides that he can go, the maximum number of rides he can go is 7. Oops, I wrote R. Maximum number of rides he can go is 7 or less, right, in the context. So, 7th grade class is putting on a variety show to raise money. It costs $700 to rent a banquet hall. They charge $15 per student. How many tickets do they need to sell in order to raise at least 1,000? Well, right, so they have to make greater or equal to 1,000, I guess, to break even. So they're paying this up front. So they're going to have to pay $700 to rent a banquet hall, I guess, graduation, plus $15 per ticket, right? Has to be great. $15 per ticket. So the number of tickets times 15 added up to $700. Wait. Sorry. Hang on. Oh no. I think I lost Active Inspire. Did I? I did. Okay, it's okay. My recording's okay. Hang on a second. Cost $700 to rent the banquet hall. They charge $15 per ticket. How many tickets do they need in order to raise at least $1,000? Okay, so they want to sell tickets, and whatever they sell has to be greater or equal to 1,000. So this is $15 per ticket. So how many do you have to sell? Well, divide this by 15 and divide this by 15. The number of tickets they have to sell in order to reach 1,000 is 66.6, bar notation, right? So if they sell 66.6 tickets, they raise at least $1,000, but because they can't do that, you're going to have to go one higher. So the number of tickets that they need to sell is 67. Last question. Trinity had $600 in a savings account. She wants to have at least $250 in the account by the end of the summer. She takes away $35 each week for expenses. How many weeks can she withdraw money from her account without going under $250? So she wants to have her account, her checking savings account, has to have a value of $250 or higher. She starts with $600, and every week making $35 per week. How many weeks can this go on? And she can still have $250 or more. Well, minus 600, we get negative 35W greater or equal to, what is that, 350, negative 350. We're going to divide both sides by negative 35. And W is going to be, W is going to be less or equal to, obviously, 10. So, up to 10 weeks, she's good. If she does it for more than 10 weeks, her account balance is going to be under 250. 10 weeks is okay. And then we point to the left because 9 weeks is good too. 8, 7, 6, 5, 4, 3, 2, 1, 0. All right, that's it. Remember, mixed match socks is your task to get the 2 points bonus.